Section 1.4 is on building functions. We're going to deal a lot with composition of functions, which is this funny notation right here if you haven't seen it before. What it means is this. We're going to do, this is read f of x. This is read f of g of x. This is read g of f of x. But you work inside out. So what it's essentially, what you're doing is you're taking x, you're plugging it into the function f, which just gives you the original function. Then you're taking that and you're plugging that back into f. So basically what I'm trying to do is take this function and plug it back into itself. If I do that, I get x squared plus 1. I always put that in parentheses, what I'm plugging in, and then just put it right here. So it'll be squared plus 1. So that would be the answer for the first one. Now, you probably want to FOIL this, I'm guessing. I don't know if Webwork will accept this or not. I guess I'll try both in a second. But to FOIL it, you'd have x to the fourth plus 2x squared plus 1. So plus 1 would be 2. So this would be f of x. Right here. And for me, Webwork accepted both of these answers, this and this. Okay, the next problem is telling us to do f of g of x. So basically do g of x first, which is already done for us right here. Here's the function, g of x. Then stick that into f. So basically I'm taking this right here and sticking it right into the domain of f right there. So it becomes x squared minus 1 in parentheses. That's going to be squared plus 1. Now Webwork will accept that. You can FOIL this out as well, and you'll get x to the fourth minus 2x squared plus 1 to be plus 2. So I'm going to put this here because it's simplified, but either answer works. Alright, for the last one then, we're going to do f of x and plug that into g. So we're going to take this function right here, we're going to plug it right in there for that x. So the x squared plus 1 in parentheses squared minus 1. You can put that there, or you can square this once again. So it'd just be this right here. Alright, next one says, understand the concepts of domain, range, and inverse function. The domain of this function right here is a set of all real numbers except we can't have negative 2 because that's an undefined value. So we can't stick in negative 2. The two things we need to look out for domains are zeros in the bottom of fractions and negatives underneath square roots. Now the range itself is a set of all real numbers except where there's a horizontal asymptote. Now on your formula sheet, it says that horizontal asymptotes occur at these three things are what you need to know. The first one says this, if the exponent is the same in the numerator and the denominator, then the asymptote is the fraction of the leading coefficients. So for us, we do have the same exponent in the numerator and denominator. So our y equals 1, which is the fraction of the leading coefficients, 1 over 1. That's our horizontal asymptote. So at 1 is an issue. Basically, if you graph this thing, you see at 1, it's got a horizontal asymptote, so that number's not, it's the only number not in our range. Now it asks me a couple more questions. What do I get when I plug in 2? Well, when I plug in 2, I get 7 over 4. When I plug in t plus 1, I get t plus 1 plus 5 over t plus 1 plus 2, which is t plus 6 over t plus 3. So you got to write that, make sure you use parentheses appropriately. And then it wants to do the composition. This is another way to do the composition. It says take t squared, plug it into function f, in which case you get this t squared plus 5 over t squared plus 2. Then take that and plug it back into f. So now I need to take this and plug it back into f. This is a tough one. So I'm going to put this in parentheses and plug it right back in. So it's going to be plus 5 in the numerator, and then it's going to be this thing again. Plus 2 in the denominator. Okay? So now I'm going to simplify this. To simplify this, I need to get a common denominator. So this is over 1, this is over 1. So I'm going to add these together. I'll multiply the top and bottom of this by t squared plus 2. Top and bottom of this one by t squared plus 2. Now I can add these fractions together. And this becomes t squared plus 5 plus 5t squared. I'm distributing this as well. Plus 10 all over t squared plus 2, and then all over t squared plus 5 plus, I'm going to distribute this as well, 2t squared plus 2 all over t squared plus 2. Now, instead of dividing by a fraction, I'm going to multiply by the reciprocal. So I'm going to multiply by t squared plus 2 over this, and I'm going to simplify this as well. This is 3t squared plus 7. So now I don't have that because I moved it up and flipped it. And then this one I can simplify as well. 5t squared plus 1t squared gives 6t squared, and 5 plus 10 gives you 15. So this is really 6t squared plus 15. Now these will cancel when I multiply, and I'm left with my final answer is 6t squared plus 15 all over 3t squared plus 7. That's the simplified answer for this last part right here. All right, more operations with functions. This one just says add the two functions together. That's all that means. So when you add them together, you get x squared plus x plus 2. And that goes right here. All you do is add them together like you would normally add functions. Next, it wants you to subtract them, so it's going to be function f, which is x squared plus 1. Now you got to subtract function g. Make sure you do it in parentheses. And so you'll have x squared minus x, and that's it, because the 1 and the negative 1 will cancel. And that goes right here. Next one wants you to multiply the function, so just take f of g of x would give you x squared plus 1, and you got to FOIL it, times x plus 1. So you're going to have to FOIL this, in which case you get x cubed plus x squared plus x plus 1. And that goes right there. Next, divide them. That's pretty simple. X squared plus 1 over x plus 1. That would go over right here. Make sure you use parentheses. And then the compositions, you know, we've done that in the previous problem, but do g first. So it'd be x plus 1, and stick that in to f. So it'd be squared plus 1. That would go right here. You can simplify that if you want. And the next one says take f, function f, and plug it into g. So take this function and plug it right in there. So you'll have x squared plus 1 in parentheses plus 1, so it'd be x squared plus 2 right there. More compositions. F of 1 gives you 1 over 2. F of t gives you, t over t plus 1, which you can enter in. Make sure you put the bottom in parentheses. X squared gives you x squared over x squared plus 1. And f of x gives you this original function. Here's f of x. Then you got to plug it back into itself, so it's going to be plus. In the top there's that, and then in the bottom you have the original function again, plus 1. Now, it's probably going to want you to simplify this, I'm guessing. So once again, top and bottom by x plus 1 of this fraction, so that you can have like bases to add the fractions. So then this becomes 2x plus 1 over x plus 1. Instead of dividing by this, multiply by the reciprocal, x plus 1 over 2x plus 1. Because they move that up, and then these cancel, and you get x over 2x plus 1. Okay, just some more practice with function notation. F of 3 and f of 4 added together, so you do them individually. 3 times 7 is 21, plus 5 is 26, plus 4 times 7 is 28, plus 5 is 33. Now add those together, and you get 59, which goes right here. Now this is different. This says do the 3 plus 4 first, and then plug that into f. So it's going to be 7. So 7 times 7 is 49, plus 5 is 54. So those are different things, different function operations. Okay, next question, once again, just two compositions. Take g, plug it into f. So that'd be 8x plus 3. And we're going to plug it right in here. So it'd be times 6. We'd have to square that plus 6. So first one, you just put this function into that right there. And I think you can enter this answer in or simplify it. I think it accepts this one though. The next one says do the opposite. So take f now and plug it into g. So then it would be 6x squared plus 6. Now that goes right in, so you have to multiply it all by 8 plus 3. And I think you can enter that answer right there, or you can distribute the 8 and simplify it. Okay. First problem says find f of g of x. All right, so we're going to take g of x, 3x plus 9, we're going to stick it in to f. So we have 1 over 3x plus 9. Okay, so now we need to look at the domain. So this would go here, and the domain is all real numbers except x equals negative 1/3. It's important also to look at the original function that you're plugging in, g of x, and make sure there's no restrictions on that. because if you can't plug in numbers from this domain, then they're not going to make them into the composition function either. So we'll see that, I'm sure, coming up in a second here. But next one says do g of f of x. So we're going to take f of x now and we're going to plug it into g. So we have 3 times 1 over x plus 9. So we can simplify this a little bit if we want, but this is the composition they're looking for. Now, you can see that we still have x can't be equal to 0. So let's try the next one then, f of x. If we plug in function f back into itself, we have 1 over x, which is now 1 over x. Okay? Now instead of dividing by a fraction, let's multiply by the reciprocal, so this would become f of x would become just x. Right? Now, if you look at this function, you'd say, okay, there are no restrictions, I can plug in whatever I want. But the only problem with that is, in the original function f of x right here, we couldn't have 0. So that means we can't have 0 still. Because what this function really is a manifestation of this composition, and we can't, in the original function, we can't have 0, so we can't have 0 in our composition. That's a tricky part. Okay? So g of x then, we're going to take this and plug it back into itself, so we have 3x plus 9, plug back into itself. So we'd have 3 here and 9 here, that goes there. And this can be all real numbers, so negative infinity, you can write that out, positive infinity. There's no restrictions on either on this or the original g of x. They're both all real numbers. Okay, next question says f divided by g is undefined when x equals. So we're going to take it and write it out real quick. That'd be x cubed plus 6x squared, all divided by 10x squared minus 8. So this would be undefined whenever the bottom is 0. So let's take a look at that real quick and write 10x squared minus 8 and find out when it's 0. Add 8 to both sides. You have 10x squared equals 8. Howdy, boss. Divide both sides by 10. And you get x squared equals 4/5. Now I'm going to square root that, and it turns out that that could be positive or negative square root of 4/5. As two things that I can't have in the bottom here, because if either of those things will give me an undefined value in this f over g function. So we'll put both of these in, separated by a comma. So it'll be, square root 4/5, comma, negative square root 4/5. Okay, some more practice with compositions and finding the domain. So the first one, f of g of x, we're going to take g of x, plug it into f. So I always take what I'm plugging in, the first one, g of x, I write that down, put that in parentheses, and then plug it right in for this x. So that'll be 5, this would be minus 1, this would all be square rooted. So you can distribute the 5 and simplify this a little bit. Webwork will probably accept this. Now the domain. My original function g of x doesn't have any restrictions, so that's fine. So let's look at this one then. Unfortunately, this one does have some restrictions. So let's simplify this. This would be 30x squared minus 30. Minus 1 would be minus 31. So I'm square rooting that. And so I need to look at when that, I need to make sure that 30x squared minus 31 is greater than or equal to 0 for obvious reasons, because I can't have negatives underneath square roots. When I add 31 to both sides, I get 30x squared is greater than or equal to 31, divide both sides by 30, and I need my x to be greater than or equal to the square root of 31 over 30. And it wants an interval notation. So that'd be the square root of 31 over 30 to infinity. And I can include this value, I can do a bracket there, because I can have that value, it just gives me 0 underneath the radical. So I'm going to try that once. Oh, made a mistake here. I actually forgot about the positive or negative. So when I took the square root plus or minus, which means that I got to do x is greater than or equal to square root of 31 over 30. But also x is less than or equal to negative square root of 31 over 30. And I'll have to make another video and put this in here because I'm out of time. And I'll do the next one and show you how to enter this in interval notation in the next video.